So let's move on. Who has finished? Who has finished? Raise up your hand. Sadiq, what's your answer?
Hey, 18.4.
You had 18.4. Who else? Some people are now doing 0.2, 0.3 as if they are doing it.
As if they are doing what?
As if they are doing it. So they are finding the expected return, right? Now,
yes, so
we know that. So Sadiq, your 18.4 is correct.
hey,
Find the weight of the investment. Now, I told you that when you have not been given the weight, what do? You find the weight. Now, we have been given 5 different investments, and we have not been given the weight. So you don't raise up your hand and tell the vigilator the weight is not there. You don't know what you are doing. Now, when you are not being given the weight, you assume equal weight for all. So in this manner, the weight now is going to be 1 divided by 5. So let me insert my equation. So the weight is going to be 1 divided by the 5 investments. So when you do that, you are going to get 0.2 for all of them. Or you do 100 divided by 5. So 100 divided by 5. And then you are going to get 20% for all of them, which is equal to 0.2. So this is your weight, or this is the weight you are going to use. So when I say expected return for this investment, that is for investment A, B, C, D, E. So we normally subscript this one. That's why you see me sending it at the down here. So for investment A, B, C, D, it's going to be 0.2 multiplied by the first one, 0.14. So this is going to be in a bracket like this, plus 0.2 multiplied by 0.16 plus 0.2 multiplied by 0.07 so the person can do it this way. Plus 0.2 multiplied by 0.2 bracket open plus 0.2 multiplied by 0.35 bracket open, then he gets his final answer to be 0.184 or 18.4%. Now, student A can solve it like this. Student B can also say, student B, who is very good in statistics, will say, but if all of them are having equal weight, then I'll just bring 0.2 here. Then I say bracket open, 0.14 plus 0.16 plus 0.07 plus 0.2 plus 0.35. 14, okay, 1607.235. So he will do all this one. Then student B will quickly get 0.184 or 18.4%. Now, take note of the second way or the second method of solving it. It doesn't work all the time. So this method, note, this method works only when you have equal weights. Where you bring only one of the weights outside, it multiplies all the returns. So this method only works when you have equal weight. But when you have different weights like 60, 70, then you decide to bring 60, 70 outside before multiplying, you get everything wrong. So this is how student A can do his own. And this is how student B can also do his or her own. So those who are waiting for us to put the solution down, then they copy. Hurry up and copy, then we move on. So this is the solution for the illustration that I've given you. And I think with these 3 strong or 4 strong illustrations that we have looked at, you should be able to find your way out if you have been given a question concerning expected return. If you have been given a question concerning expected portfolio return, so you should be able to know when they want you to find portfolio, they will tell you or they will give you the weights. Without the weights, and they didn't tell you what is portfolio expected return, then they want you to do it like the way we do the first one. So you must be able to identify the distinction between the two so that you don't be solving it like the way we did the first one to get the 7% and the 9%, but to do it like the way we are doing it now. That is my word of caution to you. Any question? If you have any question, you ask me and then I'll answer. Okay. Let's move on to the second aspect of our tutorial. Portfolio standard deviation. When we looked at, in chapter 1, we look at individual expected return, and then we look at individual standard deviation. Here to also look at the portfolio standard deviation. Now, when you are to find the portfolio standard deviation, you still need the weights. You need the weight of the investment. At the very beginning, I told you that without the weight, you cannot solve anything in portfolio. So if you don't know the weight, then you are going to be having a problem. So you must know your weight. Now, to get your portfolio standard deviation, it is equal to the weight of X or the weight of investment A squared multiplied by the standard deviation. So this symbol you are seeing here is the standard deviation symbol. If you cannot draw that symbol, just write SD. So this symbol is like 6 that you turn it to the opposite side. So how we write 6 to the opposite side? Like that. So if you cannot type that symbol, just write SD. Okay, just write SD. Everybody understand. So the standard multiplied by the standard deviation of x squared plus the weight of y squared multiplied by the standard deviation of y squared plus a constant 2. As for this 2 there, don't ask me where it is coming from. I don't know. Plus a constant 2 multiplied by the weight of x multiplied by the weight of y multiplied by the covariance. The COV here means covariance. The covariance between x and y. The covariance between x and y. So at the end of the day, that is your standard deviation formula. Now look at it. Assuming that we have 100 Ghana cedis and we want to invest 50 Ghana cedis in A. So we are still using the same illustrations so that you see the pattern. You want to invest 50 Ghana cedis in A and invest 50 Ghana cedis in B. What is the portfolio standard deviation? The very first question was asking you what is the portfolio expected return. So you see the same question, see it outside the examination, you go and see the same thing in the examination, but the requirements are different. So you don't look at it and say, hey, the question has come. You deviate and deviate big time. So you open your eyes and look at the requirements they are asking you for so that you provide the necessary answer. The painful thing is that the answer you know, where they are coming to me, the mankind question is, it's different from the one you couldn't have done it and you did it wrong. At least you know that after all, if I could have done it, I couldn't have done it. So whatever I've done, is okay. But the one you can do it and you want to deviate big time, then there's a problem. And the one that will multiply your problems most is that where you were the one who were even teaching your group members. You taught your group members and then you say, hey, Charlie, so that the thing comes, Charlie, so that they change something small. Were able to, then you, the leader, you were not able to do it. That is the problem. I get it. So you must be very, very, very careful. Sometimes I share my own personal experiences with you so that you won't go there and go and do your own thing. You teach people and then they will go and get A+, then you are getting A. Now, to find our portfolio standard deviation, we pick the weights. And you already know how to find the weight, or you already know how we got this 0.5 over here. So I don't need to waste my time explaining this 0.5 here anymore. So the 0.5 here multiplied by the 14.8, the 0.148, then you square root it. I get it. So the 0.5 multiplied by the 0.1418, then you square root it. If you square root it, then you go to the next one, 0.5 multiplied by the 11.14. So the 0.1114, then you squared, plus a constant 2. These two, the one you ask me where it is coming from, I don't know. Statisticians has placed it there. How they got it there, I don't know. So this 2 there, it must always be there. You can see it in the formula here that it is there. So it must always be there. Nobody should go and learn it and say because there are 2 investments, we are putting 2 there because they are A and B. That's why we are putting 2 there. So that when they are 5, then you put 5 there, you deviate big time. That 2 there is a constant 2. So to avoid you being confused, I will not go into the explanation of that too. So the simple answer is that statisticians has placed it there in the formula. So you to place it there like that and move on. Multiply by the weight of A. Weight of A is 0.5. Weight of B is 0.5. Multiply by the covariance between the two. Now, the question, we left out one thing here, where correlation coefficient is, so correlation coefficient is negative 0.9374. So we left out this thing in the question. So fix it in if you have copied the question. So when you have to find the standard deviation, you need the covariance, but we want covariance, and the question is giving us correlation coefficient. Now, when the question is giving you correlation coefficient, you must find it, because the correlation coefficient is equal to the standard deviation divided by what? The covariance. Sorry. Yes, the standard deviation divided by the covariance. So correlation coefficient is equal to the standard deviation divided by what? The covariance. Now, if you know that to get correlation coefficient is equal to standard deviation divided by covariance, and then now they gave you correlation coefficient, you want covariance, what do? You do change of subject to get it. I get it. You do change of subject to get it. So when you do your change of subject to get it, at the end of the day, covariance is equal to the standard deviation multiplied by what? The correlation coefficient. So covariance is equal to standard deviation multiplied by what? The correlation coefficient. So now, I know the standard deviation of A. I know the standard deviation of B. The standard deviation of A is 14.8. Standard deviation of B is 11.14. So the 14.8 multiplied by the 11.14 multiplied by the correlation coefficient between A and B will give me 0.1418 negative. Now, why is the correlation coefficient negative? At the beginning of the lecture, I told you that we build portfolios with investments that are inversely what? Related. So if the investments are inversely related, then therefore the correlation coefficient among the two must be negative. Because if the correlation coefficient among them is not negative, you cannot build a portfolio. So take note. Always in building portfolio, the correlation coefficient must be negative. So when you see a question in an examination hall and the correlation coefficient is positive, you can raise up your hand and tell them the question is wrong. And that one you have a defense. Why is it wrong? We build portfolio with negative correlation coefficient. So the correlation coefficient cannot be positive. It's wrong. I get it. So it can be that it can be a typographical error, and the positive you see that you can do it negative, and you are good to go. You are correct. All because if you know what you are doing. But for academic purposes, if you don't know whatever they give you, you do it. But when you know and you want to challenge that one, I don't have a problem with that. But you must challenge based on facts. So when you find your covariance, you are going to get this answer to be your covariance. It is this answer that we have replicated over here. This answer is what we have placed in the formula over here. So when you do everything, at the end of the day, you should be getting your standard deviation to be 0.027 or 2.7%. 2.7%. When you get this answer in business finance or in finance, you must always explain. You must always explain your answer, because somebody without an investment knowledge or somebody who is not having any knowledge in investment, these things doesn't mean anything to him or her until you explain. Now, if we said expected return is 7%, what does it mean? If we said expected return is 9%, what does it mean? If we said standard deviation is 14.18, 11.14, what does it mean? What we mean here is that whenever you pump in any money in investment A, any CD money, any one CD you pump in investment A, you are going to get 14.18. You are going to get 7%. Whenever you pump in one CD in investment B, you are going to get 9%. Whenever you pump in money in this, you are going to get it. So those are the returns you are talking about. Now, what does the standard deviation mean? This 14.18 here means that the likelihood that we are not going to get the 7% is 14.18. So the chance that whenever you pump in one CD into that business, you are going to lose it is 14.18, or let me say 14%. When you pump in one CD, the chances that you won't get it back is 14%. The chances that you get it back is 86%. So is it not a good investment? It's a good investment. Let's go in. But the chances of we getting back money is 80-something%. So the chance of we getting 7% is 87. Oh, let's go. This one, the chances of we not getting the 9% is 11.14. What are the chances of we getting the 9%? Is 89%. Oh, let's go in for it. I getting it. So at the end of the day, when you strike out your portfolio expected return, what was it telling you? The portfolio expected return of 8% was telling you that if you pump in one CD into these two investments with the ratio 50 pesos, 50 pesos, the chance is that you are going to make 8% on that money. If you pump in 20 Ghana with the ratio 10 CD here, 10 CD here, given their respective return, you are going to make 8% on the 20 Ghana. That is what this 8% is meaning here, or is telling you. When you go to that of the standard deviation is telling you that the chance that whenever we pump in money into this investment in the ratio 50-50, or in the ratio 1:1, or in the probability 0.5, 0.5, any money that we pump into this business, the chance that we are going to lose that money is 2.7%. We have just 2.7% chance of losing that money. And so therefore, it means that the chances that we are not going to get the expected return of 8% is 2.7%. I get in the probability that we are not going to get the portfolio expected return of 8% is 2.7%. So when you have been asked to, let's say, explain, so they said, oh, explain your answer. So we say that the standard deviation of 2.7 percent indicates that we are the chance of we not achieving the portfolio expected return of 8% is 2.7%. So the chances that we are not going to achieve or get our portfolio expected return of 8% is 2.7%. That is what this 2.7% is telling us, or that is the explanation to this 2.7% you are seeing over there. If you have any question, you raise up your hand. I'll call you. If you don't have any question, then next question is coming. And then you also follow suit. And then you give me the answer. So the next question, so I think the correlation coefficient is missing there. So the next question is here. Assume that so illustration 4, we are also assuming that correlation coefficient is this. So you have the next minutes to solve it, and then you give me your answer.